in listen-only mode.
Hello everybody, good morning. Welcome to aga-cad. Firstly, what I want to ask you is to raise your hands if you can hear me and if you can see my screen. You can do this on the right side of your monitor on the Go to Webinar dialog block. And I see a few of you. Yes, okay. Yes, okay, I see. So let's begin. And it is nice to see you here. My name is Jokubas Vaishvila. I'm an application engineer and project manager from Tools for Revit aga-cad Ltd. Today we will talk about sprinkler fire protection system design, and firstly I want to shortly introduce you who we are, who are the aga-cad, and who we are. So we are the authorized golden partners of Autodesk for architecture, engineering and constructions, media and entertainment, for all the Autodesk things in our country. Also, we are the authorized training center and the certification center. Also, we are the authorized developers for Autodesk, and we develop the tools and the solutions for them and for us also. And we are the pioneer in the development of Autodesk Revit add-ons and professional BIM software. Our product portfolio consists of BIM solutions and Revit add-ons under the Tools for Revit trademark all over the world. We have more than 5,000 commercial licenses and more than 5,000 free smart browser licenses in more than 45 countries. Talking about the free smart browser, you can download it for free and use for your family browsing and family transfer from one project to another project and many more things you can do. But I will speak a little bit about this further, but you can check our website in www.aga-cad.com. and you will find this smart browser solution and you are able to download it for free. We has been providing design software since 1991, so we are the first developers, first resellers, first software and service giver to the audience in Lithuania. So greetings from Lithuania to you. So this is the photo of my colleagues, and we have 20 employees with engineering and management education, and also the practical Revit experience. We have 4 departments, and that is programming. The programming department is the place from where our tools grow, and you could use them, and we could use them. Also the project management, the training department, the consulting and sales. So that is shortly about us, and we have the main goal of our company is to develop the productivity boosting products that significantly eliminates various time wasters and lead to reduced design cost and a higher profit margin. So on the left side you can see the diagram of the service price and the profit and the cost, where you can see the yellow and red cells. The red cells means the waste, non-value adding work. We love to say that it's muda, the Japanese term for that. So our goal is to eliminate this waste, this muda as we call, and to make your service price smaller or the profit bigger. So that depends on your company, and that depends on our company how we want to do that. So here we have our solutions and tool flower to accelerate your design. How we suggest to improve your working productivity. So In the very top we can find the MEP Engineering Pro solutions for Revit MEP. The first solution is smart diffusers. This solution goes for the diffusers to insert the engineering information into it from the graphical form into the numerical form, and to use this information in finding the optimal size of a diffuser or many functionality there. You can find them also at aga-cad.com. You could look, you could see, you could browse there. Also we have the R heating that goes for radiator heating systems for balancing them and for many things there. Also we have the smart hangers. It's a almost new product from us, so this goes for hanging and supporting elements, line-based elements. If I will go here, we have the BIM tree manager for the management of BIM elements. Also we have the Sustainable Design Pro that goes for building energy calculations, for cost estimation and other things. Also we have the Revit content management solutions. As I said before, we have the Smart Browser Free, but we also have the Smart Browser Pro that has much more functionalities inside of it. So you can just try the Smart Browser for free, and if you will like it, you could use the other one you could purchase. Yes, the other thing what we have is the Wood Framing Pro package that goes for Revit architecture and Revit structure, that for rafter design, for truss design, for wall design, and the Floor Plus is coming soon. The very new product from Tools for Revit is Smart Assemblies. The Smart Assemblies is a really powerful solution for making the shop drawings of your constructions, of your architectural and construction part. Here on our flower we have very productivity boosting little tools from Tools for Revit. For example, the Dynamic Legend is made for the legend, faster legend making. The Quick Dimension is for fast dimensioning. The Smart Sheets for quick sheeting, and Excel to Revit goes for transferring the Excel files into the Revit, and many more. Here we have things. Also here we have the Cut Opening Pro. The Cut Opening Pro is the solution that goes for making the holes in a building constructions. For example, if we have viaduct, we can and we have to make an opening around it, or exactly the same diameter of the duct, we have to make an opening there. The Cut Opening Pro is really good in these situations, and it can find various different things, for example pipes, ducts, and many things different. And today I will talk about smart sprinklers. This solution goes for distribution of sprinkler elements in various geometries of spaces. Also you can make here the connection of a system. Also you can make very much things here, and today we will look through what is the possibilities of our created MEP Engineering Pro part, smart sprinklers. Now I am going to my Revit project, and I have a little project here, and we will use this little project for better understanding, because when it's little you can better understand everything. The first thing what we have to do is to distribute our elements in the space, and we have the Tools for Revit Smart MEP tab where our smart sprinklers is placed. We can use the drag and drop functionality to place it here, and not to make muda, as I said before, not non-value adding work. while going every time like this. So it's the first feature of our solution. Okay, I'm just joking. So the first thing what we can do is to insert position symbols as a virtual group. So that means that we will insert the position symbols into our project. We will put them and they will be like a connection in between our space and the sprinkler heads, but it's not the sprinkler head, but it is only the connection in between them. Firstly, I will draw a pipe, maybe somewhere here. That will be the distribution pipe for our sprinklers. I will place it 100 inches above the ground. It's not the ground. Now it's the ground. And now I will make that. Okay, so I will insert the position symbols as I said before. To insert the position symbols, you have to identify something inside the space. Either you can press the button on the space mark, or on the doors, or on the window. It doesn't matter. I will use the space mark. After, you have to identify the x-axis that will go like a wall. So you can use any wall in a project to distribute your elements according x and y axes, and that wall will go for x-axis. Also, it doesn't matter what kind of a project you are using, the real Revit project or linked Revit project. If you have the linked Revit project, you can press the escape button to zoom in and press somewhere near here, and it will find the nearest wall, and it will take that wall as the x-axis here. So again, yes. And now we have to identify what kind of a position symbol we want to insert into our project. So we have the upright position marks and dependent position marks. I will use firstly the upright position marks, and you will see here a really simple dialog block for the management of distribution of our generic models of our virtual grid. Here in the top of our dialog block, you can find the element distribution area. Our solution automatically finds the lengths and the widths of our space, and here we have the possibility to change the coordination system, as we have the y on x or x on y axis. We can change that. For example, if I will take this wall, it will go in a manner like this. If I want to use the same, I pick another wall and it goes like this. So the distribution will go by y and by x axes. The second thing what we can find in this dialog block is room and space information. For example, we have the room and space name, we have the room and space number, and we have the level where our room or space is located. The constraints. The constraints here you can write the elevations of your needed elements, where your needed element should be placed. For example, I want to place my elements at 120 inches under my ground floor. Not under, upper the ground floor, and all my elements will be placed at that elevation. The second thing what you can change here is the element distribution planning. We can plan the distribution. Here we can find the real number of elements is 4. As you see, we have 4 elements placed in our space. Also, we can define the distances on x and y axes. That means that if I will use 200 of inches here, it will make 200 inches in between two elements. Let's check, and we have such a dislocation of our sprinkler elements. For example, I need 120. I recalculate everything, and as you see, in a second, everything is working in a second, and all the families is moving on just in a second. Yeah. The other functionality that, for example, I want to place not all these sprinkler heads, but I want to make only 5 by 5 elements in a rows, and I don't click to calculate my number, but I click to apply that configuration. And as you see, the same distances is now here, but they are in the middle. If you don't want to have they in the middle, but you want to have 5 by 5 sprinklers, you can not to distribute they by spacing and apply that functionality. And as you see, it will find the solution to make the distances in between elements equal, and all the things are distributed like this. So it's really simple and really good. As you see, our sprinkler positions is placed where our distribution pipe also is placed. For example, I don't want to have these sprinklers here, so I could use the offset functionality, and I will offset them by 100 inches like this. But I offset them from this side. But if I want to use the otherwise, to move them otherwise, we have created the mirror Y and mirror X functionalities for that. I could press the mirror Y and apply that to my project, and as you see, it goes from the other side of my coordination system. So here we have the factor of distance that is going together with minimum distance from wall. The minimum distance from wall defines the minimum distance of elements from the wall in a space for your own configuration of distribution of your virtual group elements. So your virtual group elements never will be in a less distance than you define here. And the factor of distance defines the multiples of distance. For example, if your factor of distance is set to 10, then the distances between virtual group elements are rounded to the nearest number, which is multiple of 10. So it's quite simple, I think so. And I apply everything. And as you see here, we have the gaps not less than 50 inches here. The next thing, what we can do, we can define the configuration data, the maximum number of elements on in X and Y directions. For example, I want only 3 elements and not more than 3 elements in my space, in my distribution of elements. I can apply that functionality, and my 3 elements will be distributed there. I will left everything like it was, and here we have the calculated data. We have where our first element is placed on X and Y directions on that coordinates. So it goes on X 66 inches, and it goes 51. The last is here. The number of rows and the real distances in between our sprinklers. So as you see, we really fastly distributed our elements in a space, and I want to do that again for my pendant sprinklers. So I will do it. I will do that fastly. Pendant positions, I want to be them here. I will calculate, will place, I will make an offset. Okay, we'll make like this. What's happening? It's they are in the same place as I wanted, and I can offset them, for example, like this. Oh, okay, brilliant. Yes, and I will do the same for this little space, and I will show you some more functionalities. Don't be bored, and I will make some interesting things here. As you see, all the sprinklers are distributed like this, and we have created the functionality of you can anytime manage your virtual group in a project. You can anytime manage. For example, I can make some changes here. I will make like this, recalculate, apply, and as you see, some changes just in a process. And now, if looking from the BIM side of the design, at any time of a project, your architect can make some changes, and you should be able to make the changes together with him. So we have created the functionality to turn on the virtual automatical updater. That means that if I will turn it on, all my distributed elements will move together with my boundaries of my space. But if I will turn off this, I could move my boundaries, and all the places will stay in the same positions as before, all the virtual group, and together the sprinklers. So it's really a really useful thing if looking from the BIM side of design. And I think that we're done with distribution of our position marks. If you have some questions, you can write them. You can write them to the GoToWebinar dialog block, and after the webinar, I'll try to answer all the things. Yes. So I saw some questions there, but I think I will move further, and after I will answer them all together. The next thing what I want to show you is the real sprinkler placement, because as you see, we placed only the position marks here, and we could use the insert sprinkler to position symbol functionality, and then you have to identify what kind of sprinkler you want to insert into the project. Is it the pendant position mark or the upright position mark? So I will use for pendant. Here we have our created sprinkler heads that you could use and that you could find in our sample project. When you will download our sample project, and for example you will trial our smart sprinkler solution, you could find all these elements inside the sample project, and you will be able to use them. And smart sprinklers, if saying truly, works with all the families. You can use your own sprinkler families, you could use our created families, you could use Revit families, it doesn't matter. So I will use the sprinkler, dry one, pendant, fully resized, hosted, and I will use this one. Okay, and in a second all the sprinklers are distributed in a space. Let's check them here, and as you see, they are in the very middle of our position mark. If we will look from the front, we are face-based elements, so they attach the ceiling. Yes, and we can place another sprinklers into the, so it's the upright sprinkler, and in a second they are distributed there. Now the second step after the distribution is connection of our sprinklers into one hydraulic system, and I will take them all. I will filter that. I will use only sprinklers, not generic models that are our planning points of sprinkler places. And I take the sprinklers, and I'm using the Revit possibilities here, and I will make the piping system, and that is all. Our elements are now in the one hydraulic system. For why is that? We have to identify that all these sprinklers are in one system because they have some flow information. Every sprinkler have the flow information, and afterwards we will see how the smart sprinklers will make some calculations according your standards that goes from NFPA standard that goes for America and Canada, I think so. The next thing is sprinkler pipe routing configurations. Here we have to identify all the things, all the routing things that we will use in our project. At the very beginning, I want to say that we have created most popular sprinkler connections. Like you can open here by double-clicking the image, and we have created the most popular connections for pendant and for upright sprinklers, and you could use any of it. Also, the same thing is going for pendant sprinkler. Here we can identify the elevation of upright range pipe, the elevation of pendant range pipe. Here we have nothing. Add a sprinkler. If the distance is less, that means this functionality adds separate pipe to sprinklers if the distance between main row and the sprinkler is less than entry distance. For example, 26 as was before. Also, we created the functionality like a connection to tap or fitting without pipe. With this option on, you are able to connect your sprinklers directly to the taps or fittings. For example, it's a Blaze Master fittings, for example. And here we have the side offsets. And the side offset horizontally, that as you see here, HO, that means the distance between the pipe and the sprinkler. Also we have the vertical offset VO from the range pipe. So it's going like this. And the separate sprinkler is placed here. After the configuration, then when you will be done, you can save your step here. You can save, and anytime you could find all these things. So as I have here a few configurations, I saved that, and I could use them in many projects, and I could use them in a future work. And now we are going to the next part of our dialog block. We are going to the standards and to the common data about our routing configurations. And here we have the standard that goes for America. As I said before, we have the standards for Europe, we have the standards also for Australia, but I want to say that it's not so not so hard to create your own standards if it's needed for your company or for exact region of your country or something like this. All the things is written in TXT files, and anytime you can watch, look to them, and make your own standards for your pipe diameter foundation, to find your pipe diameter. Yes, and you have to identify according these standards. You have to identify the exact table that is written here, TA 23.5.4. That means that we will use this table from that document, not from the document that I showed you here, but this document is placed on a paper in NFPA standard. So you have to identify the standard for the range pipe diameter finding and for the distribution pipe diameter. The next thing what you have to do is a sprinkler head adapter, to find the sprinkler head adapter. As you see, I have here many of sprinkler adapters because you can place the families into the project, and if it is possible to use them, they will show all these families here, and it will be really simple to find your needed family. I will use the generic standard transition, for example. Afterwards, we have the sprinkler pipe. I forget to explain. Here I have placed my distribution pipe, and this distribution pipe has all the routings inside, the routing preferences, and all the pipes should have the different or the same as you want, how you work. It depends on how you work. You have to create the sprinkler pipe type that will go for a sprinkler pipe, the range pipe type, also the range pipe, and the distribution pipe. I will use the standard one, for example. The next thing what we have to identify here is a sprinkler pipe diameter. We could use from all the sprinkler pipe diameter types, from the pipe types, and if you have created some pipe types, you could use them also here. The next thing is a minimal distance, HO and VO. That is not the same distances as here, but that is the minimum distance here. Yeah. So it's the distance divided the sprinkler pipe diameter, and it defines the coefficient of how many diameters of pipe you can fit between pipes. Between these two pipes, how many diameters of pipes you could place here. So, for example, the minimal distance is 3 diameters. That causes the hydraulics, because we will have some turbulence here in the corners if we will have some diameter less. For example, the next thing is the range pipe splitting type. That means where I will split my pipe. For example, I could use the coefficient, and that means that I will split my range pipe in the middle of it, and I could use the next possibility of distance, and for example, I will split that after 10 inches from the connection with some element. I will use the coefficient one to show you the real values here. Also, we have about this I will talk a little bit later, and we have to add the caps on our range pipes. We have to identify the cap. Also, we have to identify the length from the last sprinkler. How far will go our pipe from the last sprinkler? So it will go by 6 inches. in our case. The same things is with distribution pipe type, with distribution pipe splitting type, for example, the distance or coefficient, and the coefficient is placed here. And that is all. Only the main line is here. We can identify the main line, which line will be the main line for connection the sprinklers into one system. Firstly, I will show you the separate range pipe. That means that we will use the separate pipes for dependent and for upright sprinklers. And yeah, so let's try this possibility, and let's try. I will click on my any sprinkler in my space, and I will connect sprinklers to distribution pipe, and all the sprinklers in that space will connect according our created rules, our routing preferences, and our standards. It will connect the distribution pipe, and I have to click onto the distribution pipe. As you see, very fastly all the pipes are distributed in my space. It inserts the fittings, it routes everything, it makes like it cuts in the middle of our pipes, and many more things what this solution is doing now. And we could look here. I will turn off the thin line to turn on. As you see, we have such a connection here. Also, I have the straight connection for the upright sprinkler, as I made the sprinkler routing preferences here. As you see, the pendant one is going like this, and the upright is going straightly up. Here we have the splitting points. As I said, they are in the very middle of our distance from this connection, and from this connection we can check is it really like this, like I say. I have this point. How could I find the middle of that? Oh. From here to here. Yeah. So as you see, it finds the middle, and it splits the pipe in that place. I will remove my segments, my pipes from here, because I want to show you the next functionality of sprinkler pipe routing configuration. The next functionality is calibrates with mainline, and you can place only one pipe for upright and for pendant sprinklers, and we will try to make it in a place of a pendant range pipe, or maybe in upright. It has some differences here. In one way, you could not place the elements, the pipes, in the other way you can, because you have the routing configurations that we made before. One should be the bends, and the other should straightly go to upright. And I think everything is going well now, and in a second we will see what's happened, and the result, how our sprinklers are connected now. So as you see, our sprinkler, one of our sprinkler is going straightly up, and the other is going to the bends like this. And you can use various functions here, as I said before, for connection for connection of our sprinklers. Yes, so it's really it looks nice, and it's going very fast, I think so. Okay, if we have some problem that we want to place some more sprinklers into our space, but we don't want to make the distribution again, and only here we want to have fire sprinklers. We can, I will show you, we can copy that sprinklers and place somewhere here like this. Oh, I don't copy the sprinkler. Yeah, it's okay. And now I will show you how to work with that. You can connect your sprinklers at any time into the system and to recalculate the sizes of your pipes. And we could use the connection sprinkler to range pipe functionality. We have to identify firstly the sprinkler, then to identify the range pipe. As you see, it's really simple. It goes in the same manner as this, because it has the same routing preferences that we made before. Also, we have one here, but for example, I want to make a mistake. I will show you. I want to connect this sprinkler here, but I know that the distance is less if I will connect it to this pipe, and it will make some more elements in a project, and less elements in a project, and less money wasted, and everything like this. So I will connect the sprinkler to the selected pipe, and I will select this, but the solution finds the nearest point to intersect, and it intersects our range pipe, not the distribution line. And as you see, we have very nicely distributed elements in our project. As you see here, we don't have any fittings. Why it's so? I don't know, it's not possible. No, I'm joking. We have created the functionality for inserting the fittings in your needed elements. So I will press only this button, and all the fittings will go into our project very fastly. And as you see, we have inserted 7 elements into our project, and they are inserted in these places where we had like intersections of 2 different pipes. I think it's very useful, and I'm happy to use this software while I'm working with fire sprinklers. The next functionality, as you see, our distribution pipe is going all the way to the same diameter, but we don't need the same diameter because our flow is decreasing, going like this. So we can use the possibility to pre-calculate distribution pipe diameters according our standards, NFPA, in this manner. And you have to identify the very first point from where you want to start the distribution of your flow, and I will say that this is the first point. And as you see, in a second, our solution created the same things like with range pipes. It splits in the middle. It makes the connection, and it makes different pipe types here. Very nice. Very nice. Also, we have the functionality that is created for finding some elements, in a project, that is a hierarchy list, and also I can find the hierarchy at any time. For example, I want this one, and I see that my elements is going in this manner. So it highlights the elements that is going in one branch of our system. And here we have the second branch, the third, the fourth, and so many branches here. Looks like nice, really. And I think that I will show you the last functionality with our interference check. Let me see if I have the interference here. I think yes, I have some. So we have created 3 types of interferences. The first type of interference is to check the interferences in a space. I will click on my sprinkler, and as you see here, it finds all the sprinklers in this space. Or I could press the button on my position symbol, or at any place where I want. And we see that our sprinklers don't intersect the pipe. Yes, because the pipe is higher than the sprinkler. Let's try to make the intersection here. No, it's still not. Okay, like this. Now it's okay, I think. And now I will do the same. Not the same. I will check for the type. Only if I will press on this type of element, I will find the interference check only this type of elements. And I have only 28. It is all the sprinklers divided by 2 because I have 28 position marks for upright sprinklers. And let's check here. Yes, we have the interferences with a duct, with rectangular duct, with elbows, and many more things. And after this, I could use my Revit still, as you see. We could look at our project, and as you see, the solution highlights the places where it finds the clashes, the interferences. Yeah, that's really nice. And after that, you are able to move your duct, for example, and it will make again the interference check, and it will say that we don't have the clashes with such a type of element. And the last thing is the interference check with a system, with the whole our hydraulic system that is placed here, and that we will click on. Okay, now we have the 413 elements in this system, and it will go through all the elements, and it will find the exact places where the interferences, the clashes could be. It's really helpful when you are working with such situations. For example, I see that we will have the clash over here. We will have the interference in between our pipe and our wall. In such a situation, I could suggest you the cut opening product that goes from the tools for Revit that I was describing you before, and you are able to cut to find the same clashes with that solution, and to cut around these ducts, the holes. So let's check, and as I said before, we have here the clash here and the clash here. So again, you could make your decision what to do with these clashes. So that is almost all what I wanted to show you, but I want to show you the eHelp that you will be able to download the sample projects from eHelp. After you will download the trial version, you will be able to download the Smart Sprinklers demo project in metric or imperial style of units. Also, you will be able to use our created documentation for smart sprinklers, the easy way of working with sprinklers. And here is everything is written, and all the things what you could need is written here. How to distribute, how to route all the things, how to find the clashes, and many more things are written here. Yes, also the fire protection system design. Yeah, that's the webinar that you are attending now. Yeah, so I wanted to show you the getting started videos. A few days ago I recorded these videos, and you could find them here in aga-cad.com in MEP Solutions, and you can find the videos how to get started. Really nice videos of the steps, what you have to do if you want to update your sprinkler positions, if you want to make a system or update your hydraulic system. The steps and all the things are here. So if you will look through all these videos and you will read the technical documentation, you will be the pro user of smart sprinkler solution. And now I am recording our not conversation, monologue, my monologue, and I will send you it. I will place it on YouTube, and in a few days I will try to send you the trial version download page, this conversation, the link to this or the link to our created technical documentation. And from my side is everything, and I just want to say for you, thank you.